Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics SPM Trial Exam paper for year 2022, and this is Negeri Sembilan paper 2. Okay, let's get started with question number 1. This is from the Form 4, Chapter 4, System of Equation, and this is actually a simultaneous linear equation with two unknown, one linear, and one non-linear equation. So for a question like this, right, normally we make the linear as a subject, we rearrange the equation, and then we sub inside the non-linear equation. So here we have two options, either to make x as a subject or y as a subject. Now, as I always tell my student, we want to, number one, avoid fraction, right? Avoid fraction as in, we want to write y in terms of x in terms of y, or x in terms of y without involving any fraction. But in this case, we can't. You notice if I make x as a subject, I'll have fraction. If I make y as a subject, I'll also have fraction. So number two, the second thing to consider is we want fewer substitution. Now, fewer substitution means I only want to substitute once if I can, not twice or three times, okay? So if you substitute x inside, if I make x as a subject, I have to substitute twice. If I make y as a subject, I only have to substitute once. So in this case, the wisest thing to do is to make y as a subject. So from equation 1, let's make y as a subject. Let me rewrite. 3y equals to 1 minus 2x. My y is now 1 minus 2x over 3. Call this equation number 3. Then we substitute equation 3 inside equation number 2. The moment you sub inside here, we don't write your y, we write 9x followed by this bracket here, 1 minus 2x over 3. Yeah, the result must equals to negative 8. Now, notice that we can actually cancel this 9 and 3. Simplify them, you're left with 3. Now, this 3, you have to multiply inside 1 by 1. In fact, in this case, it's 3x. You multiply with 1 and you multiply with negative 2x. So here I have x squared plus 3x minus 6x squared. And the result is negative 8. So we can simplify x squared and negative 6x squared. So we get negative 5x squared plus 3 equals to negative 8. Just bring this over to the right-hand side. So when you bring over to the right-hand side, negative 5x squared bring over, you get positive 5x squared. And then you have minus 3x minus 8 equals 0. Now, what we can do next is to factorize them. Now, take note that if the coefficient of x squared is not 1, we need to take 5 multiplied by 8. 5 times 8 is 40. Now, let's work out the factor of 40. Yeah, you can do 40 and 1, 20 and 2, 10 and 4, 8 and 5. And find out the combination that gives us 3 here. I want 3. So in this case, it has to be 8 minus 5. 8 minus 5 gives us 3. So let's put double bracket like this. This will be 5x. This will be x. So one of them must give us 5. The other must give us 8. To get 5x to be exact, I need to put a 1. To get 8x, I need to put an 8. And since I want negative 3, see, end result here, I want negative 3. The bigger number 8 must be negative. Smaller number 5 must be positive. So my x is now 8 over 5 or negative 1. Now, take these two values, sub inside equation number 3. Find your y. My y is 1 minus 2 times 8 over 5 over 3. My y will be 1 minus 2 times negative 1 over 3. So the first answer, if you can use mental calculation by all means, if you can't use a calculator, it's 1 minus 16 over 5. That'll be negative 6 over 5. You divide by, well, this is 5, sorry, 5 minus 16, negative 11 over 5. You divide by 3 is 15 of 11 over 15. If you can't do it, like I said, use a calculator. 1 minus 2 bracket 8 over 5 divide by 3. Okay, so first answer, negative 11 over 15. Second answer, just change this to negative 1. So second one is quite easy, you can do mentally, right? 1 minus minus becomes a plus 2. 1 plus 2 is 3. 3 divided by 3 is just 1. But let me just show you here using a calculator. Answer y is 1. So notice 2 answers for x and 2 answers for y. Okay, moving on to question number 2. This is from the chapter function from for chapter 1. So first part, you are given a part of a graph of function y equals to hx and its reflection kx in the straight line y equals x. So you're given hx equals to x squared plus 3, find kx. Now understand this, when a graph of function, any function, in this case hx, when you reflect in the line y equals x, so what you're getting here is the inverse of function h. Yeah, when a function is inverse, graphically, it is represented by a reflection in the line y equals x. So if you want to find the function for kx, that means I must take function hx and inverse it. So the way I inverse a function is this: I always let whatever that I'm finding, in this case, h inverse x becomes y. Then I switch the position hy equals to x. Now we know that your function hx is x squared plus 3. Hy is therefore y squared plus 3. The result is x. Just bring the 3 over. Your y squared is x minus 3. Therefore, y is the square root of x minus 3. Now, I know you may be thinking, should I do a plus or minus? By right, whenever it's square root, we should put a plus minus. But you can see the original graph here is meant for the positive side. Yeah, you can see that for this graph, your x is more than 0. That means all the value here must be positive. Your y, when you reflect, they are also positive. So don't need to put plus minus. Your y, in this case, is your h inverse, which is your k. You can write k inverse. H inverse first, then you write k. Okay, just write straight away. Kx is your h inverse. In this case, is the square root of x minus 3. That's all. Okay, B, you're supposed to show that hx is now, hkx is now khx. Okay, so one thing I'd like to represent this on a diagram like this. So when you have a function, let's say k that happens first, okay, followed by function h. When h is the inverse of k, or even k as inverse of h, you know that if you do k first, followed by h, your outcome is going to be x. Because let's say I start from x, I go through function kx, let's say I get y, then I follow by function h, and since h is the inverse of k, let's say this is y, so we say hy, it will map the y back onto x. So function hkx is always going to give us x again, right? So we can reverse it even if I do, for example, khx. Khx means hx happens first, right? I start from x, I map onto y, follow on by function k. Function k will map y back to x. Yeah, so this is the same. But this is true if h is the inverse of k, and k is the inverse of h. Okay, in this case, we already know they are inverse of each other, but we need to show. Yeah, we can't just say that it's true. So I'm going to start by putting kx inside hx. I know function kx now. My function kx is x minus 3 with a square root. I put inside h. My hx is x squared plus 3. In this case, bracket square plus 3. You notice I have a square root, x minus 3 here. If I square the square root disappear. I'm left with x minus 3 plus 3. Answer is x. Okay. Now, how about khx? Same thing. I would start by putting hx inside, which is x squared plus 3. Put inside your kx. I already got my kx over here. So I'm going to put inside a square root of x squared plus 3 minus 3. Remember, k bracket is square root bracket minus 3. If I put x squared plus 3 here, I must put x squared plus 3 here. Yeah. Whether you put a bracket or not doesn't really matter. You can cancel them off. You're left with square root of x squared, which gives us x. So therefore, just write the conclusion. Sorry, I don't have space. I'm going to do over here, right? My conclusion, your HKX is therefore equal to KHX, okay? All right, so that is part B. Okay, part C is very interesting because they give us point A and B. They are the closest point on the of the graph, HX and KX, okay? And coordinate point A is now given. You're supposed to find distance AB. So here we use the concept of inverse again. So we know that, for example, if I have a function h, right? H map x onto y, okay? So it looks like this. K is the inverse of h. So K will map y back onto x. Meaning, when you have a point, for example, A here, the x coordinate is half. When you reflect this, when you go through function, when you inverse it, your x becomes y. Your y becomes x. This is half. This is 13 over 4. When you reflect this, this is now 13 over 4. And this is now y, this is now half, right? So meaning your coordinate of point B is now the other way around, 13 over 4 and half, yeah? The x value of A becomes y value of B. The y value of A becomes x value of B. The other way around, the x and y interchange. Okay, yeah. Now, the next thing is we want to find distance AB. We already know coordinate point A. We know the coordinate point B. So just use the formula for distance. The x coordinate for A is half minus x coordinate B square it, yeah? X1 minus x2 square, y1 minus y2 square. Your y1 in this case is 13 over 4 minus half square. Actually, it doesn't matter whether you put 13 minus 4 over 4 minus half first or the other way around. It doesn't matter, right? Okay, I'm going to use my calculator. I'm going to calculate, okay, the distance between them. And notice they're actually the same value. We can actually find one of them and then times 2. Let's say I show you here. This one, if I square it, I'll get 121 over 16, right? Yep. Well, you can straight away times 2. You get 121 over 8. So this is square root 121 over 8. You can change straight away to decimal, or if you want, can leave it in surd form. Okay, but surd form, we may have to rationalize this because it's an 8 here. 121 over 8. This one, you have to put a 1 over 2. You square root it. This will be, okay, this is a bad idea because your answer will be in surd form, right? So you can actually square root it, right? Correct? Maybe I put 16 straight away. Maybe I put 16 because I need to rationalize it later on. So, okay, never mind. I'll just show you the long way. 121 over 4 times 2. This is 11 over 2 surd 2. Sorry, this is 1 over 2, right? So 11 over 2 surd 2. You rationalize it, it will be 11 surd 2 over 4. Now, it's okay to leave it in surd form. If not, you can just change to decimal. Yeah, if you want your life to be easier, just change to decimal because the question didn't state that you had to give in any particular form. So 3.889. 3.889 unit. That's the distance between point A and B. Okay, question number 3. This is from the chapter Indices, Surds, and Logarithms from chapter 4. Okay, the first part, we have a diagram that shows right angle triangle ABC. Dimension of AB is given as 5 surd 5 y and 4 surd 5x. So that's the dimension AB and BC. And we have PBSR is a rectangle inscribed in the triangle ABC, where BS is given as 2 surd x, BB is 3 surd y. So we are supposed to find the value of K given that the area of shaded region is K surd xy. So very simple. We know area triangle is half times base times height. Then you need to minus area rectangle. Your base is 4 surd 5x. Yeah. Your height of your triangle is 5 surd 5y. Area rectangle is 2 surd x times 3 surd y. So let's cancel 4 and 2, left with 2. This 2, I multiply with a 5 in front. That will be 10 surd 5 times 5, 25 xy. Actually, you can just write 5 surd xy. I just show you the slow way. The surd 5x times surd 5y surd 25 xy. We can actually change this to 5 surd xy. Okay, never mind. Let me write this step by step. Okay, 2 times 3 put together, you get 6. Surd x times surd y is surd xy. So this is a 10, square root 25 is 5, xy minus 6x, 6 with the square root xy. So this is 50 surd xy minus 6 surd xy. Answer is 44 surd xy. And from here, we just compare. Because you're supposed to find the value of k, given that the area is k with a surd xy. Therefore, in this case, your k is just 44. All right? Okay, this is only the first part. I have second part to it. The second part has to do with indices. Yeah. Okay, let's see. Yeah, I'm going to start off by finding the value of the time. You're given an experiment was conducted where a substance is heated for T seconds. The temperature, capital T, is given by this equation. Find the time. That means you find the small t when the big T temperature reaches 120. So very simple. We just replace your capital T with 120 degrees Celsius. You get 2 power 2t plus 1 equals 120 plus 2t. So what we have here is a initial equation, or we call it the exponential equation, with power t here. But we're going to break this up first. So 2 power 2t times 2 power 1. Now, it's easier to use substitution. And I hope you know, when do you use substitution? Whenever you have 3 terms. Now, if you have an equation like this, for example, 2t plus 1 equals to 32, then we can change 32 to 2 power 5 and we solve it. Yeah, because it involves only 2 terms. And in fact, even if you don't have a number that can be written as base 5, let's say a base 2, like 32, we can change to base 2. If let's say I put a 7, if you have a 7 like this, then we just introduce logarithm, right? You bring the power down, you can solve for t, right? So again, this one involving 2 terms. Now, when you have 3 terms, you can see there are 3 terms here. This is considered 1 term, 2 terms, 3 terms, because it's separated by a plus sign. When you have a plus or minus sign in between them, so it's considered 2 terms. 2 terms on the right-hand side, 1 term on the left-hand side. Well, the easiest way to solve equation involving 3 terms like this is to use substitution. So, but before we substitute, we should break this up. 2 power 2t plus 1, change to 2 power 2t times 2 power t. Okay, now I hope you all know this. A power m plus n, when you break it up, is a power m times a power n. Break this up first. And then you notice the 2 I can put in front. The t and 2t, I can switch their position. Like a power m power n, we know this is a power mn, or we can put n inside, m outside. Yeah, we can switch the position of t and 2. This is 120 plus 2t. Okay, we now let whatever having power t here, in this case 2 power t, equals to another variable. You can use y, you can use anything. I use u. Okay, so it's 2u squared equals to 120 plus u. So what we have here is a quadratic equation. I can rearrange it, bring everything to the left-hand side. 2u squared minus u minus 120 equals 0. Okay, remember, if the number in front is not 1, it's 2. 2, you got to multiply 120, so it's 240. All right, you need to work out what is the factor of 240 and which combination gives us 1. Okay, one other function, of course, you can factorize using calculator these days. A lot of people know how to do that. But okay, so I want you guys to learn the proper way, yeah, of factorizing. So one other feature of this calculator, the class-based calculator, is that you can press Shift FACT, factorize. It changed to 2 power 4 times 3 times 5. So basically, it tells us the factor or the prime factor of this number. All right, so fortunately, it's quite easy to see. 2 power 4 is 16. 3 times 5 is 15. So we know the factor of 240. One of them is 16 and 15. Now, of course, there are other combinations. You can do like 2 times 2 times 2 times 3 times 5. You can say this is 4. This will be 30, right? Okay, so you can do a lot combination. But which one gives us negative 1? Well, it's quite obvious here. It's 16 minus 15. Yeah, 16 and 15. Subtract them. So we are going to put double bracket like this. One of them is going to give us 16. So that 16 will come from here. 2 times something can give us 16. 2 times something cannot give us 15. So I put 8. The other one must give us 15. This must be negative. The other must be positive. So your U must be negative 15 over 2 or 8. Yeah, 2 answers. Now, we know your 2 power t cannot be negative. Anything power t is must be a positive value. So yeah, the smallest value of t or any variable that I can put inside is negative infinity. If you put negative infinity inside, this is 1 over 2 power infinity is 1 over infinity is 0. Anything else that I put in, it can never be less than 0. So that's why 2 power t is always more than 0. But I know some people say, what if I just don't know? I'll just go and introduce logarithm, log on the left, log on the right, bring the power t in front. Then what will you get here? Now, we all know we can't take logarithm of a negative number, right? So what do you get here? You get math error. Yeah, there is no solution. Okay, so we can't take logarithm of a negative number because a number power anything, any variable is always more than 0. So we ignore the first answer. We take the second answer. And as I said just now, if you have 2t equals to a number like 8, we can change to the same base. 8 is 2 power 3. By comparison, t is just 3. Okay, question number 4. This is from Form 4, Chapter 2, Quadratic Function. So here we have a diagram that shows location of 3 football players in a football league on the Cartesian plane. Player A from opponent team tries to attack the goal of team B and team player B and player C. So given movement of the ball kicked by player A follows the quadratic function, determine the location of the ball when it lands the ground. So let's say this is a function representing the motion of the ball. It probably will land like this. Okay, so we don't know where it's going to land. Okay, so we know when it lands on the ground, your fx must be 0. So let's take negative 150 x squared plus 25, 2 over 5, x, let it be 0. Now, I don't like fractions, so I'm going to multiply everybody by 150. So you get negative x squared. 205 times 150 is going to give us 60. Okay. 150 divided by, see, picture this. 150 divided by 5, you get 30. 30 times 2, you get 60. Then we can actually take out x, or you can take out negative x if you like. This is x minus 60. We know x can't be 0. X has to be 60 because we know it is kicked from the position where x is 0. We want to find the position when it lands on the ground. It lands on the ground somewhere here when x is 60. So they say location. You can write x equals 60, or you can say the coordinate at which it lands on the ground is 60, 0. Yeah, x is 60, y 0. It doesn't it go up and down because it's on the ground level. All right. Okay, next one. In another trial, a ball from player A has been defended by player B at the location of 46 tree. Yeah, see here, he headed the ball away at point 46 tree. Wow, I'm thinking he can jump up to 3 meter high, 46 tree. Okay, it's because this is 3 meter, right? Okay, so then the movement of the ball follows this another function. Find the maximum height of the ball. So although the ball lands on his head or headed the ball here, it probably have a maximum height somewhere here. So you're supposed to find the maximum height. Now, before you find the maximum height, you need to find what is the value of P and Q. Now, from this equation, we know it passes through this function fx equals to -1/92 with the x plus p squared plus q. It passes through 2 points. The first point is 0, 0, right? So we can sub 0, 0. That means my y is 0. My x is also 0. This one is 0 plus p squared plus q. So I don't know what to do with this. Maybe you can make q as a subject, right? Or you can rearrange it if you want. So maybe I would just because I want to get rid of, I want to find p, I want to find q, right? So maybe we can just leave this out first, right? Or I will write -1/92. Okay, if you want, you can multiply. Okay, like multiply 92 is better. When you multiply everybody by 92, this becomes 0, negative p squared plus 92q. I'll leave this out. Then I sub in the second coordinate, 46 and 3. Since the ball, is headed by the opposite, by player B at point 46, 3. That means your y is now 3. Your x is now 46. You plus p squared plus q. Again, maybe I multiply everybody by 92, get rid of the fraction. This is 276. Negative 46 plus p squared plus 92q. Equation number 2. Okay, I think we can solve equation 1 and 2, right? By subtracting them. Maybe we take equation 2 minus equation 1, or equation 1 minus equation 2 also can. I think equation 1 minus equation 2, 1 minus 2. Okay, so when I minus 0 minus 276, negative 276, this is negative p squared. You minus becomes a plus of 46 plus p squared. 92 minus 92 disappear. So what we want to do is to solve for p. And here we can actually, sorry, there's an equal sign here. So here we can actually expand this bracket. 46 squared, a bit hard to do mentally. You can use a calculator. 46 squared is 2116. 2116 plus 2 times 46, which is 92. 92p and a p squared. So the good news is we can cancel out negative p squared, p squared. Bring the 2116 to the left. This is already negative 276. 2116 bring to the left. So we write negative 276 minus 2116. This gives us 2392, right? Negative 2392 is now 92p. Take this value, divide 92. Yes, my p is negative 26. Okay, now that I got the value of p, I still need to find the value of q before I can find the maximum height. In fact, q is actually your maximum, right? Q is your maximum, right? I need to take p and sub inside equation 1. So 0 equals negative minus 26 squared plus 92q. Bring these 2 over. 26 squared. Can we calculate 26 squared? What is 26 squared? Let me count. 26 negative, you square it. 676. Bring it over becomes positive. 92q. Take this answer. You divide by 92. Yep, when you divide by 92, whoop, very ugly number. 169 over 23. 169 over 23. Okay, if I change this figure to decimal, it's 7.348. Yeah, 7.348. Now remember, Q is your vertex, right? We say that if you rewrite this equation in this form, negative 1 over 92, your P is negative 26, right? square Q is 7.348, or you can write in fraction form. So this is your maximum. Yeah? So your fx maximum, or should I say the maximum height, is now 7.348. You can write, like I say, in fraction form, or you can write in decimal. But maybe decimal is easier to understand, right? Yeah, the height is about 7.3 meter above ground, then it fall. Yeah, and it's headed by the player B. Okay, question number 5. You're supposed to prove that tangent x bracket 1 plus cos 2x is now sine 2x. Okay, let's start from the left-hand side. Okay, yep. Okay, on my left-hand side, I have tangent. Tangent is just sine divided by cos. Then you have 1 plus cos 2x. Now, cos 2x, we have 3 formula. Let me write down for you. The first formula for cos 2x is cos square x minus sine square x. The second formula is 2 cos square x minus 1. The third formula is 1 minus 2 sine square x. You can actually follow or refer to the list of formula. This is given in exam. So my cos 2x, in this case, I would use the second one. Why second one? Because I want to get rid of the negative one, a positive one. You see, you have a plus 1 in front here, right? So I have to choose the formula with a minus 1 so that you will cancel out the 1 in front. So the moment you minus this off, you're left with sine x over cos x, and this is 2 cos square x. Now let's cancel this and this. So you have 2 sine x cos x. Okay, I hope you remember formula for sine 2x. Good news is there is only one, 2 sine x. We write this as 2 sine x cos x. You can refer to the basic formula again. Sine 2x is 2 sine x cos x. So we know this is sine 2x, and it is exactly the same as our right hand side. Okay, not difficult. Okay, part B. We're supposed to sketch the graph of y equals to 3 sine 2x. Okay, couple of things before I draw the full version. I like to draw one by one. I hope you understand the transformation of this graph. The first graph, if I'm going to draw, is the basic y equals to sine x. Yeah, the basic sine x graph starts from 0, it goes to maximum 1, comes back down to -1, and then return to 0 at 2 pi. So this is a basic y equals sine x. Now, if I have a 3 in front, what is the effect of having a 3 in front? 3 in front represent the amplitude. The amplitude is 3. So I stretch it higher. So it's further away from the middle line, the x-axis. So amplitude is now 3. Now, what happens if you put a 2 in front of x? If you put a 2 in front of x, that means I have to do 2 cycles. Okay, the number 2 in front represent the number of complete cycle from 0 to 2 pi. So I draw 1 complete cycle, 2 complete cycle, and I end up here at 2 pi. Now we can also think of it as a period. I hope you learned about this, right? Okay, now this is 3 and -3. Period is given by 2 pi divided by your coefficient of x. We call it b. In this case, is 2. This answer is pi, meaning this graph of sine complete 1 cycle here at pi. Yeah, but since I'm drawing up to 2 pi, it doesn't matter. We just draw 2 cycle up to 2 pi. So I do all my practice first, my rough sketch first over here before I draw a full version. So this is my full version. I hope you guys use a ruler and draw. Please don't draw using freehand. Yeah, sometimes a bit too ugly, right? So use ruler, measure accurately, right? In fact, this one, right, I would recommend that you break this down into 8 equal path, 8 equal size, like this. Okay, so it goes up from here. I put all the points to help me to get a balanced graph, because if you don't put the points, sometimes you draw your graph maybe sangit like that, or one bigger, one smaller, or some graph may be too fat, some graph may be too pointy, right? So you want to have a balanced graph. Okay, so the graph should go up Okay, sorry, I'm missing the point. Go up, touch a point, come back down, go down, touch this point, come back down, go up, touch this point, come back down, go down, touch this point, come back up. Okay. Yep. Not perfect, but it's not too bad. Okay. So, well, we just label this subsegment, but you don't have to label all, guys. Don't have to label all. Just label the important one will do it. So in this case, I the label pi over 2, pi, 3 pi over 2, and 2 pi. That's it. Yeah. Don't have to label every single subsegment of your graph. Okay. Next, we're supposed to use the graph to find the number of solutions to these equations. Very common exam question, very typical. So we know most of the time we have to use the result from part A. You can see the part A here, look at the tangent 2x, tangent x bracket 1 plus cos 2x. Okay, maybe I don't highlight the whole thing. I just highlight this for you, just for your reference. Okay, I just highlight this for you. See this? The 6, there's a 6 in front. Yeah, there's a 6 in front. So I'm going to use this result. This is B Roman 2. Use as a result 6. That entire tangent bracket 1 plus cos 2x is going to give us sine 2x. And then you have to add with 2x over pi. The result will be 4. Okay. Now, I have drawn my graph. Yeah, my graph of y equals to sine 2x. I want to use this graph to find a solution to this equation. So that means I need to arrange this equation such that my left-hand side equals to sine 2x. 3 sine 2x. There's a 3 in front. My right-hand side must equal to another graph. And my job is to draw the second graph on the same axis to find the number of intersection. Remember, the number of intersection is the number of solution to this equation. So let's bring this to the right-hand side first. 6 sine 2x is now negative 2x over pi plus 4. Then divide it with 2. Why do I divide with 2? Because I need to get a 3. Yeah, 3 sine 2x. When I divide by 2 is negative x over pi, and this is 2. So my left-hand side is already equals to this graph. My right-hand side equals to the second graph. And the second graph that I have here is a straight line. Yeah, I know some people say, how do you know it's a straight line? Because it's in the form of y equals to mx plus c. You can see here your m is actually negative 1 over pi. Yeah. Okay. And the easiest way to draw a straight line is 2 points. Yeah. We just need 2 points to draw a straight line. Normally, I'll take the smallest value, 0, largest value, 2 pi. Yeah? We use 0 and 2 pi because the graph that we are drawing is from 0 to 2 pi. Okay. So sub in x equals 0 inside this. So when x is 0, your y is 2. When your x is 2 pi, okay, picture this. If I put a negative 2 pi, I divide by pi plus 2. Cut. I got minus 2 plus 0. Minus 2 plus 2, I get 0. Okay, so I've got these 2 points. So I'm going to draw this on the same axis. Okay, let's start with 0, 2. 2 is around here. And 2 pi 0 around here. Draw a straight line. Whoops. Okay, y equals negative x over pi plus 2. Now we can see from the graph that they are 1, 2, 3, 4, 5. You do include 2 pi because the graph does include 2 pi itself, right? Remember, your y values are the same when this equals to this, right? When the y values are the same and the x values are the same, that represent what? The point of intersection. So if I were to find the exact solution, this is my solution, my x value, right? Yeah, but we don't need to find the exact solution. We can't find the exact solution using a sketch like this. We can only find the number of solution. To find exact solution using graph, then we will have to draw using graph paper, right? So from the graph, the number of solution is the number of intersection. In this case, there are 5 intersection. So the number of solution is 5. Question number 6. This is from Form 5, Chapter 3, Integration. So diagram shows a shaded region bounded by 2 curves, y equals 2x squared and y equals 6x minus x squared. Both curves intersect the origin at point 2, 8. So we're supposed to calculate the area shaded region. So my area shaded region, if I move this down, you can see this is the point intersection 2 here. All right, it's bounded by the curve on top. In this case, the curve above here is given by this 6x minus x squared. This is your y1. Okay, you minus the curve below, y2. Y2 is this, y2, which is 2x squared. So to calculate the area shaded region, we integrate y1, which is 6x minus x squared dx. The limit is from 0 to 2. We put 0 to 2 minus integration 0 to 2 of your y2. Your y2 is the curve 2x squared dx. Now notice since you have the same limit, right? And this function, you have x squared and x squared, we can actually minus them. It's actually easier if you combine them and write 6x. If you minus x squared, you minus another 2x squared. Total, we minus 3x squared. Yeah, we can actually combine them this way. It's easier. Now, when you integrate, remember, copy x, increase the power by 1, 2. 6, you divide by 2. We can immediately write this as 3, right? Don't have to do extra work. And then this is 3x cubed, increase the power by 1. 3 divided by 3, you can cancel them straight away. Immediately, we write this as x cubed. Lower limit 0, upper limit 2. Now, let's put 2 inside. So 3 times 2 squared, you can write 4 minus 2 power 3. 2 cubed is 8 minus 0. Your answer is just 4 square units. All right, so this is the first part. Okay, second part, we are supposed to find volume of revolution in terms of pi when the region bounded by the curve. Okay, here they miss out the curve y equals 2x squared. You can see the Bahasa version is given here. Lengkung y equals 2x squared. Straight line x equals to 2. So the 2x squared is this line, is this curve. Y equals 2x squared. Sorry, the other way around. 2x squared. This one, sorry. 2x squared. This one. Yeah, a bit ugly. X equals to 2 is this. Okay. And the x-axis is this. So this is a region, and you can highlight this, the region here. We're going to rotate 360 degree about the x-axis. Okay. So if you don't draw, it's okay. Most important thing is when you integrate, right? When it comes to volume, we have to integrate pi y squared dx. Your y itself is 2x squared. If you square it, dx, you're going to expand this first, yeah? Okay, so the lower limit is 0, upper limit is 2. So let's expand. Maybe I take out the pi first. I put the pi outside 0 to 2. This is 4x power 4 dx. So when we integrate, this is 4x 5 over 5. Lower limit 0, upper limit 2. Okay, so let's put them in. Okay, put 4 pi over 5 outside, put the 2 inside, 2 power 5. You can write 32. It's okay, I'll write 2 power 5 minus 0. And 32 times 4. 32 times 4 is 128. So let me write here. 32 times 4, 128 over 5. 128 over 5 pi. Or you can change to fraction. Divide by 5. You can change to fraction. Sorry, mixed number. 25,305. 25,305 pi in unit cube. Okay, now take note that we can always use your calculator to double check whichever calculator you're using. If you're using this one, just integrate. The integration button is here. So let's say let me use this to the second one. 4x power 4, lower limit 0, upper limit 2. But we drop the pi. There's no pi here. See, 128 over 5. Okay. Or 25,305 pi. Yeah. The second one, the first one, so we can integrate like this. So let's say I use 6x minus 3x squared, lower limit 0, upper limit 2. And this answer is 4. Okay. Okay, moving on to question number 7. This is from the chapter Vector from chapter 8. So here we have a diagram. OAB is a triangle. OP equals 2/3 of AO. OA. That means this ratio is 2. The whole thing is 3. Therefore, PB should be 1. Okay. Now, AB is twice the length of AQ. So that means these two are equal length. That means Q is the midpoint. And OR is 4 over 5. 4 over 5 of OQ. That means this is 4. This should be 1. Now your OX is given as 9x. So we can actually do some groundwork first. Your OA is 9x. Okay. So meaning what's your OP? Your OP is 2/3 of 9x. That will be 6x, right? That means I'm going to write here, this is 6x. The whole thing is 9x. Therefore, this should be 3x. Yeah, 9 minus 6 is 3. And your OB is 4y. Let's label here 4y. Okay, first part, I'm finding PB. So it's quite easy if you label everything. They can see from the diagram to go from P to B. I can go this way. Yeah, P to B is P to O, O to B. That means minus 6x plus 4y. Okay, let me write down. Okay, we can write here minus 6x plus 4y. You can write 4y minus 6x, doesn't matter. Doesn't matter if you put a positive in front, negative at the back, or the other way around, it's fine. Okay, second one, how to find OQ? Well, actually, there are two ways to do it, the slow way and the fast way, okay? Now, let me show you the slow way, the standard way. To go from O to Q, what will most people do? They will go from O to A and then A to Q. Let me show you here, O to A to Q. Can you see that? That is your OQ. You can also go O to B, B to Q, okay? So OA itself is 9x. AQ is half of AB, isn't it? We already know it's half of AB. And we can find AB right now. AB, you can see from here, AB is minus 9x plus 4y. Yeah, minus 9x plus 4y. So let me just write over here. This is 9x. This is half minus 9x plus 4y. Let us multiply inside 9x minus 9 over 2x plus half times 4y is 2y. 9 over 2 minus 9 minus 9 over 2, you still get 9 over 2x plus 2y. Now I want to show you a shortcut to do this because Q is the midpoint of AB. So we can do this. OQ is just vector OA plus vector OB divided by 2, right? So OA is 9x, OB is 4y, you divide by 2. Isn't it the same answer? If you split them into 2, you can see it's 9 over 2x plus 2y. Okay, it's a shortcut. You take the vector for OA and vector for OB, you plus together, divide by 2, you get vector OQ. Yeah, Q is the midpoint of AB. All right, next, part B. Hence, prove that PRQ, PRB are collinear. Well, collinear means 3 point lies on the same line. Now we already know PB. We know when 3 points are collinear, right? Okay, so first of all, when they are parallel, when 2 vectors are parallel, first vector, let's say vector A, is a multiple of vector B. So we can put the lambda in front of B. But if they are collinear, you must have a common point. So in this case, your PR, we can use PR equals lambda PB. Now, of course, there are other combination. If I use PR lambda PB, my common point is P. If I use PR equals to lambda RB, my common point is R. If I use RB equals to lambda, should I use PB? Yeah, my common point is B. So whichever you want to use is fine. But for me, I will look at what I am given, right? I am given PB. I know PB from the first part. Yeah, let me underline it. I know PB already. So it's actually wiser to use the formula with PB. Maybe I use the first one. Let's find PR, right? Okay, let's find PR. So let's just work out. To go from P to R, I can go from P to O, O to R. Okay, let me just write it down. Let me write it down. To find vector PR, I go P to O, O to R. Now, we know PO is negative 6x. OR is 4 over 5 of OQ. It's given here, 4 over 5 of OQ. And we know OQ from the earlier part here. So this is negative 6x plus 4 over 5. My OQ is 9 over 2x plus 2y. So when you times inside, 4 and 2 can cancel. So you're left with 18 over 5x plus 8 over 5y. Okay. Now, this minus 6x plus 18 over 5x, I can add them out. Minus 6 times 6 times 5 is 30. Minus 30 plus 18 is negative 12 over 5x plus 8 over 5y. So that's my PR. Okay, I've got my PR already. I know my PB. I want to find lambda. I need to show that they are collinear. So we say PR equals lambda PB. My PR is negative 12 over 5x plus 8 over 5y. My PB, I know, is negative 6x plus 4y. Okay, can we factorize them? Take out common factor. Now, you don't actually have to take out the whole everything because I can see that 12 and 6, the difference is what? 6 times 2 is 12, right? So I'm just going to take out 2. And I have a 5 here, the fraction 5. So 12 divided by 2, left with 6, but there's a negative, so I keep the negative 6x. 8 divided by 2, I get 4, so this is 4y. The 5, the fraction over 5, I can take it out as well. Now, notice from here is quite clear cut. We can cancel your 6x minus 6x plus 4y, and we can find out our lambda. My lambda in this case is 2 over 5. So if I can express PR in terms of PB, PR is now a multiple of PB. Yeah? PR, you can see, is 2 over 5 of PB. So meaning they must be parallel, and since P is a common point, therefore we say P, R, B, they are collinear. Remember, for common point, for collinear, they must have a common point. Otherwise, they're just parallel. If I can express a vector in terms of another vector, meaning they're parallel, first thing. But if you have a common point, they must be collinear. Okay. All right, I've done part B as well. Okay, third one, part C. I am supposed to find area of triangle OAB given area of triangle PAB is 12. Okay, let me highlight for you. Where's PAB? PAB is this. This area is 12. Okay, maybe I highlight this, the whole thing. This is 12. And we're finding OAB. OAB is the entire triangle. Maybe I use purple color, the whole thing, right? But we know PAB is smaller, OAB is bigger. The height of the triangle remains the same. Both triangle has the same height, let's say H. But PAB has a smaller, so I say shorter base. The base has a ratio of 1 versus this whole thing, the ratio is 3. Right? This is from the starting part, right? We know OB is 2, BA is 1. So OA, the whole thing will be 3. So I'm going to use ratio to find area of triangle OAB divide by area of triangle PAB. We know OAB, if you use your base is OA, or you want, you can write 9x, right? But if you want to write 9x, please use magnitude, modulus, because you're finding the length and magnitude. Don't write in terms of vector 9x. We need to put a modulus there. Now the height, I don't know what is it. I'm going to call it H. Whereas PAB, it is smaller. This is only 1. The ratio is 1. So this is 3x. All right. So this is H. So OAB, we don't know. PAB, we know is 12. These two we can cancel. Notice I can cancel half and half, H and H. 9x cancel with 3x. I'm left with 3. So this ratio is just 3. Therefore, area of triangle OAB is 12 times 3, 36 square units. Okay, moving on to question number 8. This is from the Form 5, Chapter 2, Differentiation. So diagram shows a round bottom flask with center O that has radius of 10 cm. Water is poured into the flask such that the depth of the water from its base h cm increases at the rate of 0.5. Excuse me. So show that the surface area of water is given by this. So now we probably have to understand, maybe draw, I'll have to draw for you a cross-section area so for you to understand this better. Surface area of the water is this, it's a circle shape. So when you increase the height, right, so the circle becomes actually smaller and smaller, right? Now this is only true up to here, up to this level. After this level already, right, then you see the height, the surface area of water is the same, doesn't change. So, but we want to know what is the relationship between the radius of the water surface, let's call the radius as r, versus h. Yeah, what is the relationship between r and h? So we can start off by saying, okay, the surface area of the water, obviously it is a circle, we can say pi r squared. But to examine the relationship between r and h, maybe I draw a bigger circle over here for you to see. Okay, sorry, my circle is not very round. Okay, this is better. So it's actually above the center of this circle O. So water level is here, is measured from here to here, is h. Now let me draw this line here. We know that the radius of this circle here is 10 cm. So this is 10, right? So let's say the water surface has a radius. If you view from the top here, right, what you see is a circle, and this circle has radius of r. Now, if this is 10 and the height of the water level from the bottom is h, yeah, this is the bottom, right? So the length from here to here should be h minus 10. So yeah, this is h, right? This is 10. This will be h minus 10, right? So what is the relationship between these three? Now here we can see it's a right angle triangle, right? So we say that r square plus h minus 10 square must equal to 10 square, yeah, by using Pythagoras. So your r square plus h square minus 20h plus 10 square is 100. I just expand them, I get 100. Let's make r square as a subject, bring everything to the right. Your r square is 20h minus h square. Call this equation number 2. So let's sub equation 2 inside equation 1. My area is pi 20h minus h square. Can you see? Well, this is my answer. All right, part A, no problem. Part B, find the rate of change of water surface area when the depth is 12 cm in terms of pi. Okay, so we want to find the rate of change of water surface. That means you're finding dA dt. Yeah, the water surface here. Okay, you're finding dA dt. Do you know any other information? Okay, read the whole question. The question really say the depth of the water from the base h increases at this rate. That means your dH dt is 0.5, right? So we got to use dH dt, right? You want to find dA dt, you're given dH dt. So we can use what we call the chain rule. Break up the dA and dt, put the dH and the dH. We already know dH dt. dA dH I can find by differentiating this. Okay. Now remember, pi is a constant. When you differentiate, for example, if I give you, let me give you an example, y equals to 3 with the x squared minus 2x. Now, actually, or maybe I don't use 2, I use 5x, okay? Just so you know, when you differentiate this, right, it doesn't matter the 3 outside. I can keep the 3, I get 2x minus 5. The constant doesn't change, right? You can multiply inside, and then you differentiate, you get the same thing, right? It's like this is your u, this is your v. When you dy dx, you copy u, differentiate your v. Now, if you go and differentiate your u, differentiate a constant, what do you get? The whole thing becomes zero, right? It's like you go and copy a 3, you differentiate this, differentiate 3, you get 0, you copy x squared minus 5x, the whole thing is 0 anyway, so you don't have to do that. I'll just leave the 3 outside, differentiate inside the bracket will do. Okay, coming back to this question, I want to find the ADT, right? So I have a pi outside. Let's keep the pi outside, differentiate inside. Differentiate 20h, you get 20. Differentiate h squared, you get negative 2h. Now, next, we want to sub in. Sub in what? Your h value, your initial value of h. Your h value is 12, right? Yeah, find when the rate of change of the water surface when the depth is 12. So let's put 12 inside 20 minus 2 times 12. That will be 20 minus 24, negative 4. You can see your dA dt is negative. So it's understood because as the water level surpass the midpoint here, O, right? So as you increase it, what happens is the circle becomes smaller and smaller. So the surface automatically becomes smaller. So my dA dt, sorry, I think I wrote this wrongly. This dA dH. I haven't found dA dt yet. This dA dH. My dA dt is therefore dA dH, which is negative 4 pi multiplied with dH dt, 0.5, answer negative 2 pi. If you want to write the unit, it'll be cm square per second because the unit earlier given is per second. Okay, but if you don't write unit, it's fine. I just leave it like this. Okay, just write negative 2 pi. Okay, and you're supposed to give your answer in terms of pi, so don't change the decimal, leave it. Next one, C. When h is 12, there's a small change in h by p%. Using the method of differentiation, find the small change in the water surface area in terms of p and pi. Okay, so delta x is a small change in x. Okay, we know that in this case it's delta h, a small change in the height. Your height actually changed by p%. So in terms of percentage, we must say p over 100 multiply with the original height. So what's your original height? When your height is what? 12. Yeah. When it's 12, it increases a little bit by p%. So you multiply by 12. That will be, you can write 0.12p, or you can write in fraction, up to you. Maybe I write 0.12p. It's easier, 0.12p. Okay, we know that when your delta H is small, delta A over delta H is approximately the same as dAdH. Now, we already know when your H is 12, your dAdH is negative 4 pi, right? So I know my dAdH, I know my delta H, I can find my delta A. Delta A divided by delta H, 0.12p equals to dAdH, which is negative 4 pi. Let us multiply over negative 4 times 0.12, negative 0.48 pi p. Okay, not? Yep. Okay, question number 9. This is from the chapter Linear Law from for chapter 6. Okay, so let's start. We have a table that shows values of variable x and y obtained from experiment. Variable x and y are related by this equation where h and k are constant. So you're supposed to plot log 10y against log 10x. Log 10y is against log 10x. Okay, all the y value and x values are given. Maybe I recalculate here. I put a LGX and a LGY. Let's write this value down. For x, right? Okay, let's start. We have to calculate log 1.26. Okay, this is a bit annoying because you have to write down one by one and leave it correct to 2 decimal. Don't need too many decimal points. 2 decimal is good enough. This is 0.10. Okay, 10. Okay, I calculate my y at the same time. So next one, my y is log 2.51. My y value would be 0.3996, round off is 0.40. Okay, 0.40. Okay, then let's continue. Log 2.09. Okay, 0.32. And for your y, log 4.27, 0.63. Okay, the next one, log 5.01, you will get 0.70. Okay, next one, log 10. Log 10 is 1. You can just put 1, right? Or you can put 1.00. Next, log 6.31. 6.31 is going to give us 0.80. Okay, and your y value, log 16.6. That will give us 1.22. Okay, then log 10. Log 10 is 1, so 1.00. And then next one, log 25. Log 25.7, 14, 1.41. Okay, last one, log 15.85, 1.2, and log 44.67, 1.65. Okay, 1.65. So I've got my x, I got my y. Okay, you're given the scale is 2 cm to 0.2 unit on both axes. Okay, so here let me zoom in and plot. Yeah, it's quite a small graph. This is 0.2, 0.4, 0.6, 0.8, 1.0, 1.2. This is LGX. Your LGY is 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.6. My largest value, let's check. Your largest value is 1.65. So I can go up to 1.8. This will be my LGY. Okay, let's just draw. Where is my... Okay, let me draw this. Zoom in a bit. Okay, it's my x horizontal axis. Okay, let's draw a vertical axis. Goes all the way up to 1.8. Yeah. Okay, this one, adjust it here. Okay, so my first point is 0.1 and 0.4. 0.1, 0.4 over here with a cross. Second point is 0.32, 0.63. 0.32. Okay, 32 a bit hard to see. So I zoom in a bit. 0.3 will be here, right? 32 will be slightly more, one more box more than that. 0.63. Now I can't exactly read 63. 63 must be in between. 62 is okay. This is 62. 63 is in between. So it's here. Okay. Maybe a bit lower in between both of them. Okay. Next one is 0.7 and 1. 0.7 is in between. 0.6 and 0.8. This is 1. Okay, next one, I have 0.8 and 1.22. 0.8, 1.22. 1.22 is here. Remember, one big box is 0.2. One small box will be 0.02. Sorry, 0.02, small than. Okay, next one is 1 and 1.41. 1 and 1.41. 1.4 is here. Sorry, I think I missed out 1.4. I'm sorry, I missed out 1.4. Yeah, this is 1.4. This is 1.6. 1.8 is higher. Sorry, 1.8 is higher. So let's move this up a little. This one. Okay. Just shift it up. Okay. Move this up. Okay, up to here. This one I should erase it. Erase this. Move it higher. Okay. So 1.41 should be here. 1 and 1.41. right? And last one, it should be 1.2 and 1.65. 1.2, 1.65, 1.65 is in between, yeah, between 2 and 3. Yeah? So, okay, you can see one point is slightly out. There's one point that is quite different, but what to do? Yeah, we have to draw the line of best fit. Yeah, make sure it passes through as many points as possible. Now, it may or may not pass through all the points. One thing, or it may not pass through the first and the last. I can see that in this case, right, maybe I adjust it. It may go up to here. See? Yeah. But one point is quite far away. Yeah. We need to adjust this a bit. Make sure it's balanced. The number of points above and below must look about the same. So I think I need to move this down a little bit. Okay. So you can see there are 2 points above, 1 point below, but this point is quite far below compared to the rest, right? Okay, the rest are okay. 3 points on the line of best fit. Yeah. 2 points above, 1 point below, I think it's fine. Okay. Just at this point over here may not be good. Maybe be a wrong value. Okay. So coming back to this, you're supposed to always remember the purpose of linear law is to find the value of unknown. Yeah. And to find the value unknown from your equation, we have to find gradient and y-intercept. Okay, my gradient from the graph, okay, maybe I start off with this y-intercept first. This y-intercept, I look at this around 0.26. So your coordinate is 0, 0.26. Okay. And now to find the gradient, right, we need a second point. So we move, for me, I use 5 boxes. I go horizontal 5 because any number divided by 5 is a nice number. So I'm going to pick this point here, which is, you can see it's 1, right? 1 and 1.41. You can write 1.41. You can write 1.4. I think 1.41 is fine. 1.41. Okay. So let's find the gradient. I'm going to calculate my gradient here. My gradient is 1.41 minus 0.27 divide by 1 minus 0. Okay, come, let's count. 1.41 minus 0.26 divided by 1. So actually don't write divide by 1. I got 1.15. Okay, you may get 1.14, 1.15. That is my gradient. My y-intercept 0.26. Okay. All right. Now let's go back to the question. Okay. Now the question over here asks us to use the graph to find the value of P and Q. Now my original function, as you can see, is y equals to hx power k minus 2. You're supposed to find value of unknown h and k. So we're going to introduce log on both sides of the equation. Keep the log y, break up log h plus log x k minus 2. The k minus 2 is the power. You bring the power in front. So it's k minus 2 bracket lgx plus lgh. This is my lgy. So this is your big Y. This is your gradient. This is your big X. And you'll see that when I say big Y, I'm referring to variable in the Y-axis. When I say big X, I'm referring to variable in the X-axis. My gradient just now, I've got 1.15. So when you bring over, my K is 3.15. Yeah, you might get slightly different answer. Yeah, it's okay. Because I got, based on my graph, I got 3.15. Yeah? Okay, my y-intercept from my graph just now, I got 0.26. My y-intercept from this equation is LGH. So to find H, we have to use anti-log. Shift log. That means 10 power 0.26. My answer is 1.820. If you round off correct to 4 significant figure, we'll do 1.820. Yeah, 1.820. I think it's okay. Yeah? It's quite accurate. Now, next one. Find the value of x when your y is 6.31. Okay, from the graph, we know when your y is 6.31, your LGY will be, let's take log 6.31, you will get 0.8. okay, I need to read 0.8 from the graph. You can see from the graph here, 0.8 is over here. Move it across, move it down. It looks like in between 0.46 and 0.47. It looks like 46, 47. You might get 46, you might get 47. I think it's okay lah. 46, 47. It looks like 47. Okay. Right here, 0.47. So from the graph, your LGX is 0.47. So to find X, I again need to anti-log, shift log, 0.47, 2.951. My X is 2.951. Okay. Hope you're okay with the graph. Huh? So there you go. Okay, question number 10 is from Form 5, Chapter 5, Probability Distribution. So here in a survey conducted at the housing area, 305 of the residents have Wi-Fi line at home. A sample of 10 people was randomly selected from the housing area. If the variance, okay, find the probability not less than 3 people have Wi-Fi line at home. Not less than 3. Not less than 3 means what? Greater equals to 3. So this is a binomial distribution. Now maybe I write here, this notation is for binomial, but if you don't write, it's okay. Your n is number of people in the sample, in this case 10. P is probably a success, in this case 3/5. Or you can write 0.6. So we want not less than 3. Not less than 3 means greater equals to 3. Yeah, it can be 3 or more. Okay. It cannot be less than 3. Okay. So what we can do is to use 1 minus 0, 1, 2. Because, okay, let me put it on the table like this. This is 0. This is your x. This is your probability. This is 1, 2, 3, 4, until 10. So when we say not less than 2, not less than 3, that means you can have 3, 4, 5, 6, until 10. But if you calculate one by one, it's going to be crazy. Right? We know total probability is, the sum of probability is 1. By using 1 minus probability of 0, 1, 2, I can find the rest of this. Okay. So, okay, let's count. 1 minus px equals 0. And remember, the formula is given by, let me write over here, px equals to r is given by ncr, small p, power r, q, power n minus r. So my n is 10, cr, my r is 0, p is 3/5 power 0. My q will be 2/5. Remember, p is probably a success, q is probably a failure, and p plus q is always 1, right? If p is 3/5, 1 minus 3/5 is 2/5. This is power 10 minus 0, which is 10. Then you minus 10 c1, 3/5 power 1, 2/5 power 9. Then you minus 10 c2, 3/5 power 2, 2/5 power 8. Okay, use your calculator and count. Okay, so there are two ways to calculate this. One, okay, actually, there are many ways to calculate this. Okay, so if you want, you can use a standard way, 1 minus 10c0. Actually, 10c0, you don't have to type because 10c0 is 1. And anything power 0 is also 1. So you're left with 2/5 power 10. Okay, let me show you here, power 10. Okay, 2/5 power 10. All right, then you minus, next one is 10c1. 10c1 is 10, so I don't write lots of things. 10, 3/5. Okay, and then followed by 2/5, 2/5 power 9. Then you minus 10c2. Then you have 3/5 power 2 and 2/5 power 8. And that will give us 0.9877. 0.9877. Now, another way to do this, because we know is between 3 to 10. whether you use this calculator, we have the same function. And let me show you this one. You can press Shift Sum. Okay. Key in the general formula. Your n is 10. Shift C. C is this one. X is an unknown. Multiply by P, 3/5 power X. Yeah. Then you multiply by Q, 2/5 power 10 minus X. So in a way, this is shorter because you don't have to do a lot of work. We want from 3 to 10. So when you type in calculator, you type the function once, but leave it in terms of X. Then you key in the X value that we want. We want from 3 to 10. You press equals. Can you see 0.9877? Okay, on top of that, this calculator has so many different functions that's really, really good. You press mode. You can also use this. 7 for distribution. Look at this. 7 for distribution. Then you press number 4 for binomial PD. Now, PD is probability distribution. So if you want to calculate one by one, right, you can go to list. If you go to variable, you're counting a single value. Like, for example, x equals to 1. Your n is 10. Your p is 305. Your calculator can find a single value for you. This is for x equals 1, the probability, right? But if you want to calculate multiple value, right, you can go to same thing, mode 7 or menu 7. You go to binomial PD again, like just now. You go to list. All right. Now you list down what we want. We want x equals to 0, 1, 2, right? Then you press equals. Your n is 10. Your p is still 0.6. Press equals. You get all this. But this one is a bit troublesome because you got to add them up, right? Now, there's another way. It's called binomial CD. PD is probability density. CD is cumulative density. Just press down here. You press 1. Cumulative density means we calculate up to that number. It's like cumulative frequency in your mod maths. Yeah. Your frequency table, we use cumulative frequency. So you press 2 for variable, right? I want until 2. I want 0, 1, 2. So when you put 2, you're finding 0, 1, 2. You press equals. There you go. You got this answer. But you need to take 1 minus because this is before you 1 minus the x 0 to 2. X equals 0 to 2 is this value. As I do 1 minus 0.1229, there you go, 9877. So whichever method you want to use is fine. If you have this calculator, of course, you can use this PD function. It's a lot easier. Just key in the x value, the n value, the p value, then you get the answer. Okay, my first part is done. Okay, now let's move on to second part. This is a normal distribution. Okay, so how do you know whether it's a normal distribution or not normal distribution? They will tell you. See, this is normal distribution. Okay, so they say this telecommunication company Maxcom provide home Wi-Fi according to the budget of the resident given the table. So then you have package A, B, and C. Then you have the speed, right? And it has mean of 4.48, variance of 42.25. So we can say it's a normal distribution. But again, this one you don't write is fine. 48, variance is 42.25. Okay, we have to find out what's your standard deviation first. Let's square root 42.25. You should get 6.5. Yeah, my standard deviation is square root of 42.25, 6.5. Okay, so the first part, find the probability that resident chooses package B. So to choose package B, the speed must be between 30 and 50. So remember, we have to standardize them. The formula for standardization is Z equals X minus mu over sigma. You have to convert from X is called any normal distribution, to Z. Z is what we call a standard normal distribution. To be able to use the table or calculator, we have to use Z. So I minus 48, your mean, standard deviation 6.5. It doesn't matter whether you write less equals or equals. In normal distribution, it doesn't matter because you are finding area under the graph. Area of one thin line is 0. If I draw like this, let's say this is 30 to 50, this area of one thin line is still 0. So it doesn't matter whether you write equals or don't have equals. So this 50, we still have to minus 48 divide 6.5. Okay, let's calculate our z value. So let's do 30 minus 48 divide 6.5. Okay, this answer is negative 2.769. Okay, negative 2.769. This is your z value. Okay, next one, just change, oops, where were we? Just change this to 50. This will give us 0.308. 0.308. Okay, so here I would prefer that you do a sketch like this. One is negative 2.769. One is positive 0.308. So the area under the graph is here. But we know we have to use this mathematical table. And this mathematical table is based on the upper tail, right? So to find the upper tail, I would need to minus this part here. As for the one on the left, we have to flip over to the right. So we say 1 minus bz. The one on the left I flip over is 2.769. Become positive when you flip over, right? Then you minus z greater than 0.308. For those who can't see it, let me show you here. 1 minus this part is 2.769 minus another one. This is 0.308. Okay, 2.769. If you want, you can use this, but it's very slow. 2.769. 2.7. Okay. Now I've hard time finding 6. 6 is here. 6 is here. You can see is this number here, 0.00289. Okay, the last digit is 9. So you have to go across and minus 9 from here. Okay, so minus 9 from last digit. So I got 0.0028, 2.769. Correct. Okay, I hope I'm right. 00. Okay, alternate 2.00 2.0028. Sorry, 2.0028. Okay, I hope I see wrongly. 2.0028. Let me write here. 0028. Okay, it's very small. 0.0028. Okay, now the second one, I want to find, 0.308. 0.308 is here. 308. This one, 0.30 is this. 8, I must minus 30. Minus 30 from the last digit. So you got to think minus 30. This is 3821. You minus 30. You get 3791. 0.3791. Okay. 0.3791. So you should get 1 minus 0.0028 minus 0.3791. You should get 0.6181. 0.6181. Okay, but I personally, I don't like to use table. It's a lot longer. So you have two options. Okay, if you're using this version, but I know a lot of people don't use this table, use either the old gray calculator or you're using this new version. Okay, so let's say if you are using this one, so just a quick one, press mode, go to equation. In this case, you go to stats, 3 for stats, press AC. Then you press shift 1 for stats. Yeah, you will have this sum distribution. Go to number 5 for distribution. Go to R. Remember, R from your mathematical table is from your calculator is R. From mathematical table is Q. Your table here use Q. Q is the upper tail, right? We call it upper tail probabilities. But here on your calculator, we call it R. We press 3 for R. So the first one, 2.769. My answer is this 0. It's a very small value. 0.0028, right? 28, correct? You see, I dropped the 8, 1, I dropped the 1. You can use this function, shift eng twice. It switches the, it moves the decimal point to the right, so it's 0.0028, so it's correct. And then if you want to find 308, right? This is 0.308. I should get 0.3790. Okay, but sometimes there's a slight difference between the mathematical table and the calculator. Calculator, sometimes they get you actually a more accurate answer compared to mathematical table. A mathematical table sometimes is because of the restriction. Yeah, when you calculate this, it's not as accurate when you use a plus minus part. Yeah, they would tend to have to round off. Okay, now how about this calculator? Well, this calculator is so magical. You can just calculate this whole thing without even standardizing it. Okay, this is what we do. Mode, we go to 7, we go to normal CD, number 2. Okay, let's say you want to calculate using the Z value. So your lower is 2.769. Your upper it goes to infinity, so you press 999. Your standard deviation is 1. Your mean is also 1. Your mean is 0. I see, you notice that I moved down, mean is 0. You press equals. Can you see you are getting the same answer here, 0.0028. Yeah, you can put shift eng, it switches the decimal point. Now, for the second one, it goes from 0.308, it goes to infinity. So your upper, you put 99. Notice, same answer, 3790. Yeah, notice the slight difference in the answer because calculator is more accurate compared to mathematical table. But this calculator, you can even calculate right from the start. As in your lower, right, we put 30. Your upper, we put 50. You know your standard deviation. Your standard deviation is 6.5. Okay. Your mean is 48. Okay. And then you press equals. There you go. 6180. Okay. Yeah, even more, a lot more faster. But we use this to double check answer. Please don't type in a calculator directly. You lose mark in exam. You still need to show your standardization here. All right. Do 1 minus and then get this answer. Okay. Now, we still got second part. Okay. If 8% resident chooses speed more than h, x greater than h, more than h, 8% in decimal 0.08, 0.08. So here we have to standardize it. We change from x to z, minus your mean, divide by standard deviation, 6.5. This is 0.08. Okay, remember, I'm finding the upper tail, 0.08, right? This is your h minus 48 over 6.5. This one you have to work backwards. If you are using mathematical table, you have to slowly find 0.08. Well, where 0.08? The closest I can get is this 0.08, but I need to subtract 8 from the last digit. So you look at this 8 here. So that means this is 1.406. You see that? That's how you read that, 1.406. Okay, coming back, 1.406. So from here, my h minus 48 over 6.5 is 1.406. Then you find your h. Okay, let's count. Let's change the mode. Okay, 1.406 times 6.5. Then I plus 48. Okay, guys, my answer is 57.13 or 14. 57.14. Okay, now the problem is this is a bit long, especially using mathematical table, right? We can use this calculator and find the z value from the probability right away. Sorry, this silver one cannot work, only the black calculator. So here you press mode, you go to 7, you go to inverse normal 3, you press your area is 0.08. Maybe we use a standard one. A standard one means your standard deviation should be 1. A standard normal distribution has standard deviation 1, mean of 0. This will give us 1.405. Okay, I think mathematical table just now I got 1.406. Slightly different, right? 1.406, 0.08, 0.08 just now minus 8, right? Yeah, I got 6. Slightly different. Okay. But like I say, mathematical table has its flaws because how do you actually possibly calculate all this and get exact value, right? Yeah. Because you have 3 decimal places, so you tend to be rounding off this value earlier. So if you use calculator, you get 1.405. You use mathematical table, you get 1.406, but that's all right. But one thing to take note, this calculator, when you inverse norm, notice there's a negative in front. That is because the calculator is set such that when you calculate this area, if you put 0.08, it's calculated from the left. That's why you will get negative 1.405 on the left. So we just flip over to the right and make it positive, right? So whether you use 1.405 or 1.406, it doesn't matter. The usage of this calculator is allowed in exam, right? You can use this, but of course you cannot use the calculator function, this one directly and get this answer. That will be illegal, right? So you need to show your working. Okay. Okay, this is question 11 from Form 4, Chapter 7, Coordinate Geometry. So diagram shows a leg which is in a quadrilateral shape, ABCD. BD is a straight line, is a straight path. So CD planning officer plans to build a new straight route connecting point C to S. Yeah, connecting point C to S located on path BD. So maybe S is somewhere here, I don't know, right? So given that the length of CS is Surds 113, find they say if h and k are integer, find the value of h and k. Okay, we know S is a point on this line, and we know that the length of CS is now Surds 113. So we start off in writing this CS equals to 113. Use the formula for distance. Maybe I start off with 2h minus point C, minus 10. So it's plus 10. And then second one is minus 3h minus 10 square root. The result is square root 113. So let's square both sides. So, and I expand this straight away. 2h, if I square it, is 4h squared plus 40h plus 100. This is 9h squared plus 60. 2 times 3 is 6 times 10, 60, 60h and 100. By the way, just so you know, a negative 3h squared is positive 9h squared. This is 2 times minus 3h times minus 10. That's why it's a positive, positive 60h, and negative 10, if I square it, is still positive 100. Okay, and 113, if I square it, is also positive 113 here, right? The square root disappear. Let's add them up. 9 plus 4 is 13h squared. 40 plus 60 is 100h. This is 100 plus 100, 200. 200 minus 113. I got 87 equals 0. Okay, I think the number is not nice. It's quite ugly, in fact. But I need to multiply this and this together and work out what's the factor that gives us 100. I think in this case, you can see a 13 plus 87 itself is 100, right? 13 plus 87 itself is 100. So I'm going to put 13h, 1h. To get 13, right? This one has to be 1 here. To get 87, this one should be 87. And both are plus, positive, positive. So h is now negative 87 over 13 or negative 1. Okay, we know that h is an integer, so we ignore this. We take h as negative 1. All right, how about the value of k? Now, because they say that s lie on this point here, so if it lies on this point, this line, right? That means the gradient of ds, must equals to gradient of maybe I call it s sp. Okay, DSSB, up to you. You can use DSDB also can. All right, my DS, right now that I know S, S, you have coordinate of H equals to -1. If I put -1 here, this is -2. If I put -1 inside here, I get +3. Yeah? So S has coordinate -2, 3. So D, we already know. Your gradient will be, let's say we use y2 minus y1 minus a +2. And then x2 minus x1. Gradient of SB, I will use k minus k minus 3 lah. And then your coordinate for B is 4. Your x coordinate is 4 minus 2. Okay. Now let's calculate. This is 6 over 10. 5 over 10. Sorry. 5 over 6. This is k minus 3 over 6. Okay. So I hope I don't make any mistake here, right? So let's find out the value. Here this is 6 k minus, yeah, this is 5 over 6. Yeah, correct. Cancel them. K minus 3 is 5, k is 8. So I've got the coordinate, the value of h and the value of k. Now, second one, I've done A Roman 1. That is, I've got the value h and k. A Roman 2, I'm going to determine whether CS is the shortest walkway from C to S. Remember, the shortest distance from a point to a line is a perpendicular distance. Now, if this is the shortest distance, CS and DB must be perpendicular to each other. Now, we already know, or you can say CS to DS. DS, DB is the same, doesn't matter. Maybe I use DS here. See DS, I've got the gradient already, right? I just have to find the gradient of CS, okay? So for CS, since I know the coordinate, I use 10 minus 3. I'm using this one, 10 minus 3, and minus 10 minus 2. So this is 7 over 8. That's 7 over -8. We know gradient of ds. My gradient of ds is 5 over 6 here. So gradient of ds times gradient of cs, by right, it should be -1. Your ds is 5 over 6. Your cs is 7 over -8. When you multiply together, I get -35 over 48. Now, which is not -1? If it's not -1, meaning they are, should I say, angle DSC is not 90 degree. If it's not 90 degree, meaning CS is not the shortest walkway from C to S. Okay, don't have to write for that. I'll just say it's not the shortest walkway. That will do. Okay, next part. Let me continue with this. Let's move down. I need some writing space here. There is a stall selling drinks at point E, located on the AD route. Okay, so I don't know where is it. Maybe it's here. This is E. And point E divides a straight path AD according to ratio 1:2. So find the coordinate of the stall. So we have to use the ratio formula. Yeah, the divisor of line segment. Remember, the formula goes like this. XY is nx1 plus mx2 over m plus n. Then you continue with ny1 plus my2 over m plus n. So the most important thing when you use this is that the m and n must be opposite. For example, the m and n, the coordinate, you must multiply in the opposite direction. So your n, you must times with x1, y1. Your m, you must multiply with x2, y2. So here the coordinate point E, let's take the n1, multiply -8. The m2, multiply with half, divide by total ratio 2 plus 1. And then let's take n1, multiply with the y coordinate -2. Your n is 2, multiply -4, 2 plus 1. You can write 3, total ratio is 3. So here you get -8 plus 1, -7. Divide by 3. Second one, -2 minus 6 is -8. Divide by 3 is not a nice number, I would say, but it's okay. I think it's fine. Yep, answer can be in this form. Okay, this one is a mistake. This is negative 10. Minus 2 minus 8 is minus 10 over 3. Yeah, it's not exactly a nice coordinate, but it's okay. You can have answer in fraction. Okay, moving on to question number 12. This is from your Form 5, Chapter 8, Kinematics of Linear Motion. So here, diagram shows particle P and Q. They move along a straight line. Particle P and Q move along a straight line. P starts from point A, moving with this velocity. So maybe I will expand this, expand the bracket 2t square minus 8 minus 3 is minus 11t plus 12. Okay, expand first. All right, and VQ is given as this formula. So distance between them is 6 meters. Okay, first part, state which particle has constant acceleration, justifying your answer. Okay, we know velocity function for P. Let's differentiate the, remember, differentiate velocity, you get acceleration. As I differentiate this, I get 4t minus 11. You can see here, acceleration of particle P is actually a variable, right? Because it depends on the value of t. Yeah, you have t inside. For different values of t, you get different acceleration. So therefore, it's not a constant. Now, whereas for a velocity of q, you can see is minus 2t plus 6. If you differentiate, you get negative 2, right? So therefore, we can see from here, particle q has constant acceleration. Yeah. By differentiating both, comparing, then you can actually justify your answer. Okay, next one. Find the range in T when particle P and Q are both moving to the left. Okay, P is moving to the left when the velocity function is less than 0. So this one we can actually factorize them. 2 times 12 is 24. Factor of 24, this one is 24. Which one gives us 11? 8 and 3. 8 plus 3 gives us 11. So I will need to put 4 here to get 8, 3 here. So both minus. My t is 3 over 2 or 4. Let's do a sketch, right? This is 3 over 2. This is 4. Less than 0, the region should be below here. Move it up. Okay. Your t value is in between these two. Okay. For your q, we know our velocity function is also less than 0 here. So we bring over 2t more than 6. I bring this over instead. 2t more than 6. T is, okay, when I bring this over, t is more than 3. So we can combine these two. We can see the first one, right? The t values between 3 over 2 and 4. The second one, t value is more than 3. So this is in between. This is greater than. So the overlapping region is this. So your t value should be between 3 and 4. Yeah, the range of values of t is 3 to 4. All right, next one. I'm going to move this down a little bit. Now, the next one we're finding, part C, find the displacement of particle P when Q is stationary. Okay, Q is stationary when your VQ minus 2t plus 6 is 0, t is 3. Actually, we already got t equals 3 from here. But to find the displacement of particle P, we must first find what is your displacement function for P. We can do that by integrating the velocity function of P, this one. So when you integrate this, we copy 2, copy t, increase the power by 1, divide by the increased power. This is 11t, increase the power by 1, 2, divide by 2, integrate 12, 12t plus c. Now we need to find the value of c. Now in this case, a bit unique because both particles, they don't start at the same point. When t equals 0, you can see at t equals 0, where is particle P? It is 6 meters to the left of point O. O is your starting point, your reference point. So we say when t is 0, SP is -6. Therefore, your C is -6. Your SP is 2 over 3 t cubed minus 11 over 2 t squared plus 12t minus 6. So what we need to do is to sub in t with 3. My SP is 2 over 3. 3 cubed is 27. 3 squared is 9. 12 times 3 minus 6. Okay, let's use our calculator and add this up. This is 2 over 3 times 27 minus 11 over 2 times 9 plus 12 times 3 minus 6. Okay, my answer is -3 over 2. Yeah, -3 over 2. Okay, so the displacement, you can write 1.5 or -3 over 2. Displacement of particle P is -3 over 2 meter. Okay, lastly, find the distance traveled by particle Q in the first 6 seconds. Okay, we know the particle Q actually changes direction when t equals to 3. Okay, here you can use integration, but one thing I want you to know, if your velocity of your particle Q is a straight line, I think it's easier to use the graph. Okay, now let me explain how to use a graph, right? So let's say I sketch the graph VQ is -2t plus 6. This is a graph with a negative gradient and y-intercept of 6. So this is 6, right? Now, we know it stopped instantaneously or stationary. It is stationary when t is 3. So where is 6? 6 should be here, right? So you want to find the total distance traveled in the first 6 seconds. The total distance it traveled is actually given by area under the graph. And my area under the graph is this two, add together. So by using area, okay, so I just have to use half times base times height, then I times 2. I don't have to calculate the second one separately. Just because they are congruent, right? They're congruent triangle. Just find one of them, multiply by 2, then you get your area. Your area will be 18 meter. Now, if you don't want to do this, you want to use integration. You want to say, oh, I want to find distance travel. SQ will be find my displacement function first, or you can just integrate and say, okay, this is from 0 to 3 minus 2t plus 6 dt. Then the second one, I integrate from 3 to 6 minus 2t plus 6 dt. But take note, the second one is negative because it's below the t-axis. You either put a negative in front or you modulus it. Yeah, either way. Yeah. So, and since they're equal, can I just write 2 times of this? Yeah, I know they're equal, right? So I just integrate the first one. Okay, let me move out a bit. This will be t squared divided by 2, cancel the 2 and 2. This is 6t, 0 to 3. Let's sub inside. Minus 9 plus 6 times 3. So 18 minus 9 is 9. 9 times 2, still 18. So you can just use one of these two methods. But for me, use a graph is a lot easier because straight line graph is easy to find the area under the graph. I don't need to use integration. Just use area of triangle. Okay, question number 13. So diagram shows the prices of 4 ingredients used in production of a cake. So find the value of x, y, z. Okay, we have to use the formula for price index. We know the price in year 2021. This is from index number form 4 chapter 10. X divide 12 ringgit and 50 cent times 100. You get 104. Okay, so to find the x value, let's take 104. Everyone, take 104. Multiply by 12 ringgit and 50 cent, divide 100. Yeah, my answer is 13, right? So x is 13. Okay. Or in this case, the 13, you can write 13 or 13.00. Okay, maybe I put 13.00. Doesn't matter because it's price in RM. Okay, for y, right? Y is a price index. So we take 450 divide by 3 ringgit times 100. Okay, 450 divide by 3 ringgit times 100. So I got y is 150. Okay, how about z? Z is a price in the base year, year 2015. The price in the current year is 6 ringgit. Price in the base year is z times 100. my index is 125. So for me, I bring maybe 6 times 100 first. 6 times 100, 600. Bring the Z up, bring the 125 down. You divide by 125. My Z is 4 ringgit 80 cents. So this one is already in RM, just write 480. Okay. All right. So the first part is okay, not difficult. Second part, the composite index for the cost of making a cake in 2021 based on 2015 is 134. And the cost of a cake in 2015 is 62 ringgit and 50 cents. So calculate the cost of a cake in 2021. Okay, they actually gave us the composite index, the price in year 2015, and you're supposed to find the price in year 2021. Remember, the composite index actually tells us the overall cost. So now let me write B Roman 1. The composite index tells us the cost. The base year is 2015. The current year is 2021. So the price in 2021 on top, price in base year below times 100. This composite index is 134. The price in 2021, we don't know, right? The cost in 2021. The cost in 2015 is 62 ringgit 50 cents. So that means that overall the ingredient has gone up by 34%. 6250 times 134 divided by 100 gives us 83 ringgit and 75 cents. RM, 83 ringgit 75 cents. Okay, so this is B Roman 1. For B Roman 2, you're finding the value of W if the quantities of the ingredient P, Q, R, and S used are in this ratio 251W. Okay, 251W. So the composite index we already know. We know Y is 150. Okay, the ratio is 251W. Remember, to find composite index, we must take the individual price index, multiply with the weightage, take the sum, add together, divide by total weightages. So in this case, the first one is 104 I times 2, 150 I times 5. Okay, maybe I should draw a bit below here, no space. Okay, let me write starting from here. 104 times 2, 150 times 5. Okay, another 150 here. They are double 150 here. Another 150 times 1 and 125 times W. Divide total weightage. My total weightage is 2 plus 5 plus 1 plus W equals composite index 134. Okay, so let's add this up. This will be 104 times 2 plus 150 times 3 times 5 times 1. So I put times 6. And then this answer will be 1108. 1108 plus 125W. This is 8 plus W. Answer 134. So 1108 plus 125W is now, take 134, you multiply by 8, that will give us 1072 plus 134W. Okay, 1108, you minus this answer, you get 36. And 134 minus 125 is 9W. W will be 36 divided by 9. W is 4. All right. So lastly, the cost of the cake in the year 2018, if the cost to make the cake increased by 24% from 2015 to 2018. So again, it's quite similar to B Roman 1 here. You already know the composite index. It is given here from 15 to 18, increased by 24%. So the index is 124, right? Or maybe I write P18, P15 times 100. This is 124. P18, we know it is, we want to find the price, 2018. Price 2015 remains the same, right? We know it is 62 ringgit 50 cents times 100. Just multiply over, let's take 124. Multiply 6250. Divide 100. So what do you get? 77 ringgit 50 cents. 77 ringgit and 50 cents. Okay. Okay, question number 14. This is from Form 4, Chapter 9, Solution Triangle. Okay, so here we have two triangle joined together at point at line QS. It's a quadrilateral PQRS. You're supposed to find the length of QS. Okay, number one, you're given this angle 80, 35. I think we need to find this angle first so I can find the length of the opposite side. And then we can use sine rule. Remember, a sine rule comes in a pair. You must have angle, opposite side, angle, opposite side. So to find angle QPS, okay, let me write here. Angle QPS, we take 180 minus 80 minus 35. That would be 65. Yeah, this angle is 65. So to find QS, right, we divide by the opposite sine of the opposite angle, sine 65. Then 9.2 divide by sine 35. Okay, this is sine 35. Okay, calculator. Let me write here 9.2 over sine 35. Then you multiply by sine 65. So this answer gives us 14.54. Yeah, give your answer correct to 4 significant figure. We'll do a 14.54. Okay, now next, we're supposed to find area of quadrilateral PQRS. Okay, before you find area of quadrilateral PQRS, we need to find area of both triangle and then add them up. Now we know this length, 14.54. Okay, actually, there are two ways to find area of this triangle here. Now look at this, the yellow triangle here. There are two ways to find it. We can use Heron's law, or we can find this angle first using cosine rule. Then we find area by using half AB sine C. Now, first I would like to use Heron's law, because Heron's law, not to say faster, it's actually about the same number of steps. However, if you look at part B, later on in part B, they want you to state the size of angle QRS. So if you use Heron's law, you still need to find the angle later on. You still need to find angle QRS. So that's why in this case, I think I'll just use cosine rule to find angle QRS first, then I use half AB sine C. Okay, now even cosine rule, there are two versions. I hope you all know A square equals to B square plus C square minus 2BC cos A. We use this first version if you're finding the length of an opposite side of a given angle. The angle must be flanked by two other sides. We call this an included angle. But if you're given length of 3 sides and want to find the angle in between, so I have to bring this over, bring this over. Let me derive for you the second version. Cos A is B square plus C square minus A square over 2BC. So this is the formula for second version of cosine rule that we use to find an angle in a triangle that given 3 sides. So let's write cos angle QRS. Your B, let's start with 6.5, I square it. Your C, 12.4, I square it. Minus opposite side, 14.54 square. Divide by 2 times 6.5 and 12.4. Okay, let's use a calculator. 6.5 square plus 12.4 square minus 14.54 square divide 2 times 6.5 times 12.4. Okay, use your calculator. Now, although you get negative answer here, it doesn't matter. Yeah, the negative answer here tells us that the angle is obtuse. Shift cos answer equals 95.48. So QRS is 95.48. Okay, now I want to find area of triangle. Yeah, because we want to find area of quadrilateral. That means we need to find the green one. This one is a, sorry, let me use. We want to find the green one and the yellow one. Okay, let's start with the yellow one first. My AB sine C will be 6.5, 12.8, sine 95.48. Then you add the green one, half A B sine 80. Okay, calculator, half 12.4 6.5 first, 6.5, 12.4 sine 95.48. So then I think we can just add them up straight. Half, 0.5, 9.5, 14.54 sine 80. So this answer is 108. Okay, I hope I didn't make any mistake. 6.5, 12.4 sine 95.48. Second one, okay, this one is 9.2. Sorry, 9.2. I wrote 9.5. Sorry. This is 9.2. Half 14.54 sine 80. Okay, let's count. 105.98 should be correct. You can use 106.0 for SF, but yeah, you want to use more decimal point, is okay. 105.98. So that's your area. Now, lastly, you're supposed to sketch a triangle A Q prime R prime S prime, which has a different shape from triangle QRS, such that the length QR and Q prime R are maintained. So I'm going to maintain this length. This length going to be the same. All right. And QS also maintain. The angle QSR equals Q prime S prime R prime. This angle also maintained. Now remember, this is called the idea or the concept of ambiguity or ambiguous case. Ambiguous case means what? The existence of more than one or two possible triangle for a given measurement. So that happens, right, when the opposite side of a given angle here is shorter than another given side. You see, 6.5 is shorter than 14.54. So number one, you're going to establish that the opposite side of a given angle, the angle that you have to fix is QSR, that's shorter than another side. If it's shorter, number two, we need to identify the joint or the hinge. This is a hinge, right? Then I can take this from this hinge. I can either flip inside or I flip outside. So in this case, maintaining the length of 6.5, I can just extend this line. Now, obviously, if I flip inside, it's not going to help because cannot form a second triangle. But what we can do is we can extend this line outside and draw a second triangle outside here. So this will be my R prime, right? So flip it out, that these two sides are equal length, also 6.5. 14.54 also maintain. This angle over here, we also maintain. Now, you don't even need to know what is this angle. So let's just draw a second triangle in this direction. So please make sure you maintain the shape and the size. This is your Q prime, R prime, S prime. This is 14.54 cm, 6.5 cm. This angle you don't need to know. And that's about it. Okay. Now, then they say, last part, yeah, my triangle is done. Hence, state the size of QRS, Q prime, R prime, S prime. Okay, so going back to this triangle that I've drawn for you, maybe I rub this off. We know this angle previously is 95.48. That's why I say it's better to use cosine rule to find this angle first, because the next part, the last part, I need to find this angle over here. Okay, now notice that if you extend like this is a straight line and these two are isosceles. So your angle QRR prime, or should I write here QRR prime, is actually 180 minus 95.48. That will be 84.52, correct? So these two are equal angle. This angle, they are the same because this is isosceles. Therefore, angle Q prime, R prime, S prime is also 84.52. Yep. That's all. Okay, last question. So here we have the question from chapter 7, form 5, chapter 7, linear programming. So here, a shop sells two types of printer, P and Q. The price of printer P and Q are RM 1,500 ringgit respectively. The shop sells X unit of printer P, Y unit printer Q. So they are based on the constraint given. So the first part, Roman 1, the number of sales or the sales of printer Q exceeds the sales of printer P by at most 40. Number printer Q is Y. Printer P is X. When I say Y exceed X, we say Y minus X. If it's exactly 40, we write equals 40. When we say at most 40, we have to write less equals 40. Maximum is 40, right? If it's at least, then we put greater equals. At most, less equals. Yeah, one is minimum, one is maximum. Okay. So next one, total sales is at most 50,000. One printer X costs 500. So maybe I put a 500 here, right? Sorry, printer X is 1,000, not 500. 1,000. Printer Y is 500. Total cost must be at most 50,000. 50,000 total sales. So here I can divide by 500. So when you divide 500, 1,500 is 2. This is 1Y. This is cancel the 500. You get 100. There you go. 2x plus y less equals to 100. Okay, I've got this two inequality done. Okay, next. Roman part A done, part B. Okay, the third constraint is represented by the shaded region on the graph, right? Right inwards the constraint. Okay, so what can we see here? X equals to 3y. X is what? Number of printer P, right? So the number of printer P, we know this is X greater less equals to 3y. Okay, remember you read when you see the shaded region is based on y. So 3y is actually above, right? Greater equals x. So x is less equals to 3y. So when you read this, you have to read your x. Number of printer, I mean, when we start reading from x, right? So you must change the symbol. Instead of more than, it's now less than, right? Number of printer P sold is less than. You can say less than, or you can say not more than. Maybe I should not more than, because less than cannot be equals, right? Is not more than. Okay, guys, I better zoom in a bit. Hard to write. It's very, very small here. Not more than 3 times the number of printer Q. So number of printer P sold is not more than 3 times the number of printer Q. Okay, right. Next one, part C. Use a graph on to construct and shade region R that satisfy all the 3 constraints. Okay, so actually the third one I don't have to draw. I just have to draw the first 2. So let's just move this over here. I'm going to draw a table of values before I draw the graph. Okay, so the first graph that I have to draw is y equals to, let me move this up a bit. Y equals to y minus x equals to 40. So let's use 2x and y value. Let's start with x equals to 0. When x 0, y is 40. Take a second point. When x is, maybe I put 20. When x is 20, 20 plus 40, y is 60. Okay, we just need 2 points to draw a straight line. So this one, okay, maybe I build a table first for both. The second one is 2x plus 1y equals to 100. Let us use x equals to 0, y is 100, y equals to 0, x is 50. Okay, I got these 2 values already. So the first one, 0, 40, 20, 60. 0, 40 is here, 20, 60 is here. Let's draw a straight line. Okay, now extend the line. It goes all the way up here. So this is my first line. Maybe I should draw a bit darker. Bit hard to see. And let me just increase the thickness. Okay, a bit darker. Okay, adjust the position here. Can you see? First point. The second point, let's move it. Yeah. The gradient is 1. Okay. I think it's okay. All right. So this is the first line. This is your y minus x equals 40. Okay, the second line is 2x plus y equals 100. So 0, 100, 50, 0. 0, 100, 50, 0. 0, 100 is over here. 50, 0 is all the way down over here. Okay, so let's adjust this. There you go. Okay, maybe I need to think it's okay lah. Bit a little bit off, but it's okay because the graph paper here is a bit out there. Okay, so I've got this equation y, should I say x plus 2y equals 100. Okay, now let's go back to your region. You're supposed to shade the region. Your inequality earlier is y minus x less equals to 40. So since they shaded this earlier with shading, so I'm going to use a highlighter, easier to see. Your y minus x must be less than equals is below here. Okay, and then 2x plus y less equals 100, it must be below here. The third inequality is already given. The shaded region is already shown that it's above us. So we can just highlight all this and notice that your final answer, your R, should be here. Yeah, normally we use a symbol R, a region R to represent, the shaded region. Okay, so my region is done. Okay, next one. All right, using the graph constructed, find the range of number of printer Q if number of printer P is 30. Printer P is X. Find your Y. When your X is 30, what's your Y? Okay, let me use a blue color pen. Your X is 30. This is blue color. You can see, this is 30. Your Y has a minimum value of 10. Sorry, a bit ugly. 10. Maximum value of 40. You can see from here, 40. You're finding the range of values of Y. So your Y value is between 10 and 40. Okay. Now, lastly, the maximum profit that they're able to make is if the profit of selling a printer P is 200, profit of selling printer Q is 150. So we need a profit function. We call this an objective function. 200x plus 150y, we let it be k. And I need to find out, using the graph, the maximum value of k. Before that, let's just make y as a subject. 150y is negative 200x plus k. Yeah, y is 200 divided 150 is now 4 over 3x plus k over 150. Now this 4 over 3 is negative. So we need to draw a line that represents this objective function. But remember, your k is a variable. So your y-intercept depends on your k value. Your y-intercept is variable, but the gradient is fixed. Your gradient must be negative 4 over 3. So we need to draw a straight line. Normally we use a dotted line, but it's okay if you use a solid line here. So 4 over 3 is like this, okay? You can draw anywhere as long as the gradient is 4 over 3. So I use 40 and 30 here. Notice I use my y and x-axis to measure my gradient. Okay, my gradient should be like this. So now let's take this line and move it up and down. Wonder I can copy this. Let me copy and paste it. Okay, right? Let me copy and paste it. Paste over here. Okay, so let's take this line and move it. Okay, a bit hard for me to show you. Okay, I tell you what, I will just draw another line. Okay, can I move it? I can't move it. I can't move it up. It's okay. So I will just draw another line that goes in the same direction, that's parallel, right? It looks like this. This is parallel line. So I'm going to move this up and down and find a point that gives us the largest y-intercept. You see, take the edges here. This point here doesn't give us the largest y-intercept, right? At this point, it does give us the largest y-intercept. See this? This point here? Let me highlight this point. At this coordinate, your y-intercept is the largest. And that happens when your x is 20, your y is 60. So we write here, 2060. So yeah, your y-intercept determines your k value here, your k over 150. So from here we can say, let me zoom in a little bit. We can say that k is maximum at 2060. So the maximum value of k will be, take this and sub inside your original function here, 200 times 20 plus 150 times 60. Okay, let's count. 200 times 20 plus 150 times 60. My value is 13,000. So the maximum profit that you can get is 13,000. Okay. All right. Okay, so that is the end of our discussion for this paper. I hope you guys learned a lot in the process. Thank you for watching this video. I hope to see you in the next one. Bye-bye.